Hello, this is Mr. Huff. Let's take a look at an example problem. It might look something like this. So we're considering a 5-acre lot. It's a construction site, so it was farmland before. We've added a parking lot, and we're going to continue development. But right now, we just have the parking lot. So we want to know the site runoff after construction of the impermeable asphalt parking lot. And really what I'm after is the runoff coefficient and then the change in runoff. So some information you're going to need is the rainfall intensity. And this is from a rainfall intensity map or that estimates table. I usually prefer the estimates table. I think in the problems I give you, I'm just going to give you a number because we've already talked about finding that in last week's problem. All right, so we have a parking lot and it is 2 acres. And the entire lot was 5 acres. So we take 5 acres minus the 2 acres we just turned into parking lot. That leaves 3 acres of farmland. Okay, so that's our 2 areas. We have area 1 and area 2. All right, the next part is our runoff coefficients. So C1, this is the conservative coefficient for the parking lot. So when you're looking at that table, you're going to look, it gives you a range and you're going to choose the highest one, and the highest one is 0.95. And then the runoff coefficient for farmland is the average of the 2 numbers that you see for farmland. This is on the data table that I gave you about stormwater runoff. You can find this on the right side. But if you average the 2 numbers together for farmland, you get 0.18. And then, so what we're going to do is find the composite runoff coefficient, or C sub C. And this is going to tell us after the development what has happened to the watershed characteristics, so that we can find what has been added. So generally what you have to do is whatever the runoff rate is before you start, you have to figure out how to match that or mitigate the runoff. So we want to know what is the composite runoff coefficient and what is the change in the runoff rate. And I'm going to put a couple of steps together when we do this, but you just follow along. Okay, so keep these numbers in mind that we just went through. 5 acres, rainfall intensity, the areas, and our coefficients, values that we're using. So I did this in kind of a table form. I have C1 and A1 and C2 and A2. And over here, C1 is 0.95, A1 is 2 acres, and C2 is our farmland, so it's 0.18. And there's 3 acres of that. So if you took, remember we did 5 minus 2 to get 3. And then our unknown, what we're looking for the composite coefficient. So we can find the runoff of each one of these individually, but we want to kind of put it all together to represent the entire site. And then we're going to find the change in runoff rate in cubic feet per second. This is our first formula here. And this is on your table. It also includes some ... That just means keep going and keep going. So what you're doing is you're taking the product of the runoff rate and the area plus the product and the runoff rate and the area. So in this case, we have parking lot, we have farmland, and we could have sidewalks, and we could have lawn, and we could have, there's a whole list of things. We could have brick and forested and driveways and pasture and a cemetery and a railroad and a playground. So you would take all of those into consideration. You're just multiplying those, getting the product and adding those products together. And then you add together all the areas at the bottom to represent the whole. So you're kind of finding like a percentage kind of behavior here. So when I plug this in, I use 2 parentheses here. This is real important because we want to force order of operations. This first calculation is all in here. The other way to do this is do the multiplication first, write those numbers down, add them together, write that number down, and then divide that by the sum of the 2 of the areas. So in this case, 0.95 times 2, this is our parking lot. 0.18 times 3 is our farmland that remains, and 2 plus 3 is the total acreage of the lot. If you plug that into your calculator, you get this runoff coefficient that's composite. This number represents the runoff coefficient of the combination of farmland and the parking lot together. So that's what that means. Go to 4 important numbers for my problems and you'll be fine. So if you have a bunch of numbers after that, just stop after the 4th one. That's important, all right? So one thing that we never tell you guys is the formula for delta. Delta is final minus initial. So if you want to find delta, you take the final minus the initial. So in this case, we're looking for the change in runoff. So we're going to take Q2 as our final runoff. And this is with our composite coefficient minus our initial runoff. So we could say Q2 minus Q1. And what we're going to do, what that's going to look like is this. So our delta Q, let me go ahead and put this in here. Delta Q, I'm just replacing Q with these values. We have our CF value, which is found from that runoff coefficient adjustment factor. In this problem, we're looking at a 10-year rain period, which our adjustment factor is 1. So we're going to take, so that's what CF is. That's from that, at the return period table, okay? Then we have our composite coefficient times our rainfall intensity times our total area minus the return period, that factor there, CF, times the original runoff rate or the runoff coefficient and times the rainfall intensity times the area. So the two that we are real interested in, this is, it's not the color I wanted. Composite runoff coefficient is from the math we just did, and this runoff coefficient is just the farmland alone, what it was before. So if I know those two numbers, everything else kind of the same. There's some opportunity to factor some things, but I'm not going to worry about that right now. So plug in the numbers. So we're going to have 1 times 0.3485, that is our composite coefficient, times 2.5, our rainfall intensity, times 5, our acreage, minus 1 times 0.18, farmland, times 0.25, our rainfall intensity, times 5, our acreage. And if you do that calculation, you get a change in runoff rate of 2.1 cubic feet per second. So as a designer, you would have to figure out what to do with this additional 2.1 cubic feet per second during a 10-year storm to keep the runoff from being uncontrolled. So that's just a quick walkthrough of a problem that includes finding the change in runoff rate and finding the runoff composite or the composite coefficient. That's what we're looking for. All right, that's enough for now. Thanks for watching.